all the time about optimization. Optimization, optimization, optimization. It is the most heard word in the world of quantum computing and even in software development, new technologies like new batteries, and of course in the computing world. Optimization of algorithms, optimization of data structures, optimization of performance, optimization of a chip design, optimization of power consumption, and so on. But we often ignore what is the cost of all of these optimization. Is it worth it comparing to the price that you have to pay, the price that you have to pay to optimize? Do we sacrifice something in the name of optimization? The question is nice to ask. However, the answer is shocking. What we may think we optimize, it might be simply an illusion or potentially leads to suboptimal or worse outcome. Then the question becomes, what is the cost of optimization and how we can achieve the ideal optimization without sacrificing other important factors like resilience, flexibility, and the long-term sustainability, for example. Let's find out. And the following is my personal view and experience on this topic. A few years ago, a colleague of mine recommended a nice book to me called Optimal Illusion: The False Promise of Optimization by Coco Crum. The book discusses how the pursuit of optimization in modern society often leads to suboptimal outcomes. She argues that our relentless drive for efficiency, while appears beneficial, comes at a significant cost. Crum traces the historical roots of optimization from its origin in mathematics and economics to its pervasive influence in contemporary life, like in global supply chain, financial market, to our daily schedules and healthcare and education. One of the key points she makes is that we often trade the resilience for optimization. For example, in modern society, the peaks of efficiency and performance are often brittle and susceptible to the collapse when facing unexpected disruptions. I have finished my master's and PhD in computational sciences, and I'm now working in quantum computing and information and quantum AI applications and teaching. I use optimization every day in my life. For example, geometry optimization for molecular structure is used to find the lowest energy of a molecule's potential energy surface by adjusting the bond lengths, bond angles, and for example, the dihedral angles until the configuration with the lowest energy is found. Similarly, in quantum computing, we optimize quantum circuits to minimize gate counts and the depth. So we would like to make the quantum circuits shorter and smaller, which can lead to more efficient algorithms and reduce error rates and also computational cost. So far, so good. Optimization is a very good thing. Nature also is optimizing itself, and it's mainly is about lowering the energy of a system, which is a good thing, and we can see this in the construction of molecules. Coming to human life, like in logistics and travels, we can see other sides of optimization, and also we can observe the cost of optimization. When you would like to travel, what you do? Maybe your first thought will go to consider the limitation of your budget. How much do I have to spend or I can spend on this trip and the time of travel, and perhaps this would influence your the choices that you are gonna make. For example, do you want to travel fast or cheap or both? Can you really get both? Of course, there is no free lunch, so maybe will be hard to get. So for example, for a trip between Amsterdam in the Netherlands and Paris in France, or from Amsterdam to Lyon in France, you can check the maps and you have several options. You can take, for example, a flight, you can take the train, or you can drive yourself. Each option has its own cost and time considerations. Traveling by car is relatively, on average, the cheapest option, especially if you are having a family or you're traveling in a group of friends. Of course, it will take the longest time. Flying is often the fastest option, but of course is the most expensive in most of cases, especially when you have the cost of your luggage and your items that you would like to take with you. Then the budget of your flight will be higher. Also, you need to consider, for example, some factors: the cost of getting to and from the airports, the parking, or the cost of transportation, and the potential baggage fees that you might have. The train is often a middle ground, being faster than a drive, but usually cheaper than flying. So in this situation, you optimize for a particular goal. You might end up with a suboptimal solution for another goal, but you would like to optimize one thing. It is now the cost of your trip. You would like to make it shorter. So when you do this, you sacrifice other factors as well. So let's imagine you opt for the most cheapest option, which is, for example, renting a car or driving your own car with your family or group of friends. And when many people do the same thing, you end up with a system of individual optimization that can lead to congestion and inefficiencies. For example, if everyone decides to drive to work and save money, the roads will become congested. All the traffic will become in, and all roads will be blocked, and you will move slowly. So that will lead to longer and longer travel times, and of course, increasing the fuel consumption. So hence, sometimes individual optimization lead to collective inefficiencies. Similarly, in the context of urban planning, optimizing for car traffic can lead to cities that are less walkable and less friendly to cyclists and pedestrians. This can create a vicious cycle where more cars lead to more congestion and also more traffic jams, which in turn leads to more people opting to drive, further increasing the problem. So here we see the hidden cost of optimization. Another example would come from the housing tenure and housing market and real estate. Optimization can lead to a lack of affordable housing, for example, if developers might optimize for profit by building luxury apartments and prime locations. Those luxury apartments and the luxury places might take significant portion of the land, and leading to having very expensive units and very large units, while there is other small apartments that can afford the same facilities and the same options as these big units. This can drive up prices and make it difficult for lower income individuals and the families to find affordable housing with the same surfaces. This can lead to social inequality and a lack of diversity in neighborhoods. Now we come to science and the technologies, where optimization is often seen as a key to drive a progress. In software development, optimization can lead to faster and more efficient code, but it comes at a cost. It can also make the code more complex and harder to maintain. For example, optimizing algorithms for speed might involve using advanced data structures or techniques that are not easily understandable by all developers. This can lead to situations where the code is optimized for performance, but it's like a black box for most of the developers, and it is very difficult to maintain and update. When it comes to AI and machine learning, we can see the same issue. Generalized large language models, LLMs, are often optimized for performance and not for energy or sustainability. Training these models require massive amount of computational resources, which demand significant computational power and energy, leading to significant environmental impacts. However, the way out could be in hybrid solutions, as we are going to see shortly. I would like also to mention an example from quantum computing as a last use case. Optimization is very crucial for the development of efficient quantum algorithms. You can see, to bring a quantum computational advantage, you need to have these high quality quantum processors to deliver this value for you. You might end up operating on large quantum processors with many qubits, more than you actually need, leading to increasing problems in complexity, but also potentially in errors and noise, further consuming more energy than necessary, which is not sustainable in the long run. So what you are gonna optimize in quantum computing? So there are a lot of examples, more and more. I can go forever indeed. However, now we have seen optimization, and we have seen several use cases from different fields and domains, and even nature. What is the aim of it from optimization? In summary, while optimization is often seen as a positive goal, it can lead to unintended consequences and suboptimal outcomes. So sometimes the pursuit of optimization can result in systems that are less resilient and perhaps will not work on the long run. It could also be faulty on the long run. However, the solution comes in hybrid optimization, which balances multiple goals and considers the trade-off involved. It is like a multidimensional optimization. Such trade-offs also need to be optimized with respect to the available constraints. For example, in case of large language models, instead of optimizing for just the performance and calling a full model for every query, can use a hybrid approach that combines smaller and more efficient models with larger ones. This could be done by a larger model that provides a general understanding and of the context of the prompt, while smaller models handle specific tasks derived from these prompt or queries. In this way, we can achieve a balance between performance and energy efficiency and even speed, reducing the overall environmental impact of AI systems, but also significantly reduce the energy consumption involved in the process. This approach is not new, and several startups and the big companies now are around the globe are trying to use this approach. Like, for example, IBM, they have several open source codes, and the open source small models are available on Hugging Face, which are trained and optimized for specific tasks like coding and documentations, weather forecasting, quantum computing, and so on. The same also is applied in urban planning and the transportation. Hybrid solution can also be effective. Instead of optimizing for just one mode of transport, cities can develop integrated systems that can combine public transport, cycling, driving, walking, and even taking car sharing and ride sharing into consideration as well. For example, they can optimize public transport routes and bike inside the densely populated areas in the cities more than the car traffic, while also providing incentives for people to use public transport and cycling instead of driving. This can lead to more efficient and sustainable transportation system which benefits everyone. When it comes to areas outside the city, like in the countryside, optimization can also be done with the goal to optimize for car traffic and public transportation more than cyclists. The Netherlands is quite famous in this regard, having optimized hybrid solutions for both public transport and car traffic with well connected train system and extensive cycling infrastructure. Similarly, for code development, an architecture approach can be used to optimize which part you need to optimize in your code. You can optimize the critical parts of your code that require high performance and has performance bottlenecks. For example, more flexible and easier to maintain, and not to optimize it to the Fortnite level. So the modular design of the code can lead or can help in this regard. Some modules can don't need to be updated much or be optimized every time or even further. And some modules you will need frequently to optimize. So in this way, you can achieve a balance between performance, maintainability, and reducing the overall complexity. In this way, you can achieve the balance between performance and maintainability, reducing the overall complexity of the code base and the time used in developing and the development process. When it comes to urban planning and real estate market, the answer is obvious. What you are gonna optimize? Do you optimize for luxury levels, or do you optimize for having space for everyone? Or would you like to consider both for the sake of economy, like to match the different tastes? So imagine if we are on Mars, technically in our imagination, everyone will have a certain space. This space is equipped with a bathroom, there is tables, there is bed. You have the necessary or the necessities that you need. However, here on Earth, some will prefer to have a palace with everything that all of this space is not proportional to or the number of households inside this property. Hence, the hybrid optimization could be done. You need units to be sufficient for people to match the low income class and also maintain the taste of the luxury places for those who can afford those units, but not to emphasize one layer on another. We need the variation to not be high and to flatten the curve of the Gaussian distribution. This is an example of the multidimensional optimization. You need to optimize in a society for several factors: for the income, for the necessities, for the space, for the available resources, and so on. When it comes to quantum computers, we can see now companies are developing hybrid architectures that combine classical and quantum computing efficiently. Quantum computers, they don't work on themselves. They need classical computers to drive them. They are like an extra hardware that can perform specific tasks for you. Moreover, the way that the quantum processors are designed and connected can also be optimized to reduce the number of qubits needed for a specific task and allow for parallelism, for example. Imagine you need, for a certain algorithm, you need a certain qubits. You don't need to activate the whole map of the qubits. You need to activate a portion. So here is the modular design will help reducing this and make the quantum computer more efficient. The less qubits and the optimal number of qubits that you would like to have for your algorithm, that will lead to less noise, less errors, but also less energy consumption and higher quality results for yourself. So using many quantum processors or a modular design of quantum computing circuits can lead and also can help in this regard. IBM next year is gonna test or introduce a proof of concept of demonstrating the first example of scientific quantum advantage and fault tolerant module to show this way of optimization to benefit from or to have a business quantum advantage from the available quantum hardware. Hence, we can see clearly that optimization is not a straightforward process and it is not one size that fits for all solutions. It requires careful consideration of the trade-offs involved and the potential unintended consequences. It is a hybrid approach composed of multiple layers. Each has its own optimization and optimized goals and constraints. It is a hybrid or higher dimensional problems. It's a multidimensional process that need to be considered, need to be crafted carefully, and need to be designed efficiently in order to do so, but not to optimize part of the space and leave the other factors while this might impact them and reducing them. Again, there is no free lunch, but we can make the lunch affordable for everyone if we take and use the correct hybrid multidimensional optimization model. Hopefully you like this episode. Don't forget to like and subscribe. Until then, see you next time in Open Lab.